All right, in this lesson, we are going to represent a linear relation given a description of the situation. So example number 1 reads, Adam is flying a drone. Right now it's already 10 feet up in the air. Its altitude increases at a rate of 2 feet every 3 seconds. Represent the altitude in feet of the drone after S number of seconds. So it kind of tells us our two variables here. Remember, our variable is a changing quantity, like a changing number. So represent the altitude. It says that one of them is altitude of the drone after S number of seconds. In this story, it starts with 10 feet up in the air. So it seems like we're really talking about altitude here. Altitude is our dependent variable. So altitude measured in feet. Remember that our altitude will ultimately depend on, you can think about it as it comes after, it's the effect of the time. So S, the number of seconds. Don't forget that our y-intercept is our starting point. So where do we think about our dependent variable? Where does our altitude start? Our altitude starts, Adam's flying a drone. Right now it's already 10 feet up in the air. So our altitude is at 10 feet, starts at 10 feet. So it's going to be 0, 10. Make sure this 0 goes first. It will be 0 and then y. I'm actually going to do this first. You'll put it in this format, 0, comma y. In our case, after 0 seconds, it's 10 feet up in the air. So before the altitude increases, you could also say at the beginning, before the altitude, well, I'm going to put like this though, before the altitude increases, it is already at 10 feet. So that means it's already 10 feet up in the air. Now this slope, this constant rate of change, our slope, it says that its altitude increases at a rate of 2 feet every 3 seconds. These are pretty easy to identify because it's usually just a rate. So 2 feet every 3 seconds. So our slope is 2 over 3. I'm actually going to do this. So 2 feet 3 seconds, which is 0.66 feet every 1 second. Now let's write what that means in words. It means that the drone's altitude increases. We're going to put 2 feet every 3 seconds. And instead of writing the whole thing over, I want to use the unit rate just because I want to. That means that the drone's altitude increases. Instead of 2 feet, we'll put 0.66 feet every 1 second. That way we don't have to write the whole thing twice. Our table. So our table, our dependent variable is the altitude, and that will be the effect of time, so seconds. At 0 seconds, the altitude is already at 10. Don't forget that we're going to put the triangle A here, change in altitude, and the change in seconds here. So it says that the altitude increases 2 feet every 3 seconds. So the altitude will increase by 2 feet every 3 additional seconds. So let's put a couple more of these. So 2 more feet. I'm going to write that a little bit. An additional 2 feet after an additional 3 seconds. So 0, 3, 6, 9, 12, 10, 12, 14, 16, 18. That's better. So dependent variable goes on this y-axis, so altitude, seconds. In this case, well, I guess we just put 0 here, 1, 2, 3. Now, in this case, though, I need to go all the way up to 12. Let's check and see if it goes up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it works. So 12. And, oh, but we're going to run out of space because we're increasing. So I am going to I'm going to write this little thing. Make sure you write it if you skip. This means we're skipping. So I'm going to put 12 like right here. And that's where my first point goes. Now the altitude increases by 2 every 3 seconds. Okay, so actually what I want you to do, you have 2 different ways of doing this. So I'm going to graph all the points first. Oh, that's not 12. That should be 10. That was my mistake. 10, 0, 10, 0, 10, 0, 10. We start at 10. I looked at 12 by mistake. So let's start here. And we can do 3, 12. 3, 10, 11, 12. And we can go to 4, 5, 6, 14. So that's 12, 13, 14. But if you can tell, there's like a pattern already. The altitude goes up 2 every 3 seconds. Up 2 every 3 seconds. So I can actually find the next one if I just keep continuing. So I'm going to draw my line. And there we go. So our equations, well, let's back up a little bit just to make sure. So the altitude started at 10, and it increased 2 every 3, 2 every 3, 2 every 3, 2 every 3. You could have also done that by just graphing the points, 0, 10, 0, 10, 3, 12, 6, 14, 9, 16, 12, 18. It's whichever way that you prefer. So equations. Okay, so our altitude is our dependent variable, and it starts at 10 feet. And it increases 2 feet every 3 seconds. So 2/3 of a foot every second. We could also say that the altitude starts at 10 and increases by 66 hundredths repeating, well, 60.66 repeating feet for every second. So it starts at 10 feet and it increases 0.66 feet every second. We can also say that the altitude is equal to 2/3 of a foot for every second it was in the air, for every second the drone was in the air, plus the initial 10 feet it was already up in the air. I'm going to say that again. We can say that the altitude is equal to 2/3 of a foot for every second the drone was in the air, plus the initial 10 feet it was already up in the air. And we can say that, or we can rewrite that as that the altitude of the drone was 0.66 feet times the number of seconds plus the initial 10 feet it was up in the air. So it's about 66 hundredths of a foot for every second it was up in the air, plus the initial 10 feet it was already up in the air. And lastly, let's prove one of these equations. I'm going to use this first one. So the altitude should be equal to 10 feet plus 2/3 of a foot for every second. Okay, there we go. In this situation, you can choose any of these. For our purposes, let's say from 0, away from 0 and 10, just because 0 acts iffy. It'll work, but let's just stay away from the 0 right here. So 3, 12, 6, 14, 9, 16, 12, 18. I'm going to choose 9, 16. So 9 seconds will give me 16 for the 16 feet out for the altitude. So I'm going to write the 9 seconds first. So 2/3 times s, 2/3 times 9. Actually, what I'll do is I'm going to see how it says 9/16. I'm going to write that right here. 9/16. And I want to make sure that you do this too. Make sure you do this too. Make sure you do this too. But seconds and altitude. That way I can see if you made a mistake. I can just see the mistake if you make it, or see why you made the mistake. So number of seconds is 9. The altitude should be 16. And let's multiply here. So 9/1. 2 times 9 is 18. 3 times 1 is 3. Cool. Well, let's make that a little bit nicer. I don't know what's up with my 8s. Okay, there we go. 18/3. So 2/3 times 9 is 2 times 9 is 18. 3 times 1 is 3. 18 divided by 3 is 6. And 10 plus 6 is in fact 16, like it should be. Remember, the point of doing this is to prove that our equation fits with our table and our graph. It's not foolproof, it's just some evidence. So that is it. Thank you.